Hello and welcome to this second video about the production problem. On the first video, I wrote a mathematical model to solve the problem, the production problem. On this video, I'm going to use Excel server to find the solutions, find the optimal solution. So just to remember what this problem is about, there is a company that manufactures boat engines, and is planning the production for the next 9 weeks. So the demand for the next 9 weeks is here, 0, 0, 28, 10, 7, 15, 10, 18, and 25. There is a production cost. If the production is done in regular time, which is the cost is 1.5. There is an overtime cost of 4.5 for each unit. And there is a holding cost. If you want to have an inventory at the end of each week, the cost is 0.1 per engine per week. Now there are some constraints. The constraints are there is a limit for regular production, overtime production, and holding and units in inventory. There's a maximum number of units in inventory that can be held in inventory. There is also planned maintenance. So we have, out of this 9 weeks, we need to take 2 of those weeks in order to perform maintenance. And during the maintenance weeks, we cannot produce anything, either on regular or overtime. So we have to decide when we're going to perform maintenance and how we're going to produce in order to meet the demand. The mathematical model involves 3 sets of variables. So the first set, there are 2 sets of variables which refer to production and storing the number of units. So those variables are integers. And then we have a binary variable that's going to tell us when are we going to perform the maintenance, in which week maintenance is going to be performed. Now this model, if you want to see how this model was done, please watch the previous video with number 1 of this production problem. So the objective function aims to minimize the total cost. We have the cost for regular, overtime, and holding. Then the constraints, there is a set of 9 constraints that refer to demand. When we have the available units, they are going to be used, the production is going to be used either for meeting the demand or storing units at the end of the week as an end inventory. We also have constraints for the limit, the maximum number of units that can be produced each week, either regular or overtime. There is a maximum number of units that can be stored, and here are the number of weeks. 2 weeks are going to be used for maintenance. So, in order to solve this problem, well, I have here already a table prepared. This is going to be the variable table, so we're going to have here the variables. And we have 4 types of variables. So first of all, we have the regular production. Have regular production, overtime. And we have the number of units stored in inventory. And also we have the maintenance. And we have each of these variables for the next, for the next 9 weeks. So I'm going to leave this space that is in yellow is going to be left for the variables. And in order to find the objective function, let's write here objective function. The objective function aims to minimize the total cost. So minimizing the total cost, in order to minimize the total cost, well, we have to follow the formula. Well, the formula is the cost times the sum of all the units that are going to be produced, either regular or in overtime, and also the cost for storing, the holding cost for storing units in inventory. So let's add another column to this table where we have the total number of units, and this is going to be the sum of all the units produced in regular time. Then, of course, if we drag this, we're going to have the sum of all the units produced in overtime and all the units stored in inventory. Let's write here the cost. So we have 1.5 per unit in regular production, 4.5 in overtime and 0.1 as holding cost. So the objective function is going to be the sum product of cost and the sum Now, we already have the objective function. Let's go to the constraints. So the first constraint, we first need to know how many units we're going to have available for in order to meet the demand. So we're going to follow these constraints. That means whatever is produced either on regular time or overtime, minus the number of units that are going to be stored at the end of the week, that has to be equal to production. That's for the first week. And for the rest of the weeks, for week 2 to 9, we're going to have what is produced plus the beginning inventory, which is the same as the end inventory of last week. And we only need to subtract the number of units that we're going to store in inventory at the end of the week. So what I'm going to do here is I'm going to write, let's write here available. So available units are going to be the units we're going to use to meet the demand. So that is the sum. For the first week, this is the sum of regular production plus overtime. And we have to subtract the number of units stored at the end of the week. These are the available units for week number 1. Now for week number 2, the pattern is going to change. We're going to have regular production, overtime, plus the beginning inventory. That's the number of units left or stored in the previous week. And we just need to subtract the number of units that we're going to store at the end of this week. And this pattern is going to be the same for the rest of the weeks. Now the ending inventory in week 9 will, I know that may be some inventory for the next time horizon or the next planning horizon. So these are the available units, and these have to be equal to the demand. So let's have the demand. The demand was 0028, 10, 28 units, 10 units, then 7, 15, 10, 7, 15, 10, 18, and 25. Now, that's the first constraint, the first set of constraints. The next set of constraints involve the maximum number of units. So we have maximum capacity. Let's call it regular capacity. And regular capacity is going to be 15. It's going to be 15 for all weeks from 1 to 8, except for week 9, capacity drops to 10. This regular capacity. Now, how many units are we? So regular capacity, let's go to the formula, to the mathematical model. Regular capacity is this one. It has to be less than or equal to the so the production, the regular production has to be less than or equal to the capacity, only if we're not going to perform maintenance that week. Okay. So production, regular production is going to be, it has to be less than the capacity if we're not going to perform maintenance. So we're going to have here the number of units produced regularly minus this number, which in this case is 15, times 1 minus the variable that's going to tell us if we are going to perform maintenance or not. Now remember, maintenance is a binary variable, so you can only take the values of 0 or 1. If it's a 1, then the maximum capacity is 0, becomes 0. That means we cannot produce anything on that week. So for now we have a negative 15 and 10. Okay, and this has to be less than or equal to 0. Now, why 0? Because if we look at the constraint, what we're doing is subtracting this from the regular production. So we're left with 0 on the right side. We have to do something similar to the overtime production. So let's write here overtime capacity. And overtime capacity is 8. It's 8 for weeks 1 through 8. And in the end, it increases to 10. We have 10 units. And we have overtime production. And overtime production is going to be something similar. We need to take into account how many units we're going to produce in overtime minus this number multiplied times 1 minus the binary variable, the one that is going to tell us if we're going to perform maintenance or not. So if we're going to perform maintenance on that week, then overtime capacity becomes 0. That means we cannot produce. And this has to be the same. Oh, why do I have 1? Sorry, this should be 0. There you go. Now, of course, the constraint is this number has to be less than or equal to 0. So what are the constraints we have? We have maximum number of units in inventory. So inventory, this is the maximum. The maximum inventory, and there is no change in this. It has to be 7. So in each unit, we can store at most 7 units in inventory. Those are the constraints. Now, do we have all the constraints? We have this set of constraints. We have this set of constraints. We have this set of constraints for demand. We have this set of constraints for the limit, the capacity limit. And now we need the binary variables. We have constraints for the binary variables. So let's have the sum. The sum of the binary variables has to be less than or equal to, not less than or equal, has to be equal to 2. Equal to 2. Okay, so 2 weeks are going to be maintenance, only 2 weeks, and of these numbers, 2 of these numbers are going to be 1, and the rest are going to be 0. Now we have some special constraints. Some special constraints, which are these ones, the ones at the end of the model. So week 1 and week 2 we cannot have maintenance at the same time for both week 1 and week 2. So that means if this one is a 1, then week 2 is a 0, or if this is a 1, then week 1 is 0, or both can be 0. But these two have to be less than or equal to 1. So let's write here constraint B. And constraint B is the sum of week 1 plus week 2. And this has to be less than or equal to 1. And constraint C. Constraint C, the last constraint of the model before the non-negativity, is week 3. If week 3 is 1, then week 7 has to be 1. Now this can be a 0, and week 7 can be 1. It doesn't matter, but the constraint is for week 3. If week 3 is 1, then week 7 is also a 1. 3, so this one is going to be week 3 minus week 7 less than or equal to 0. Okay, so this is the Excel. This is the Excel. We already prepared an Excel page in order to use solver. So if we go to data solver, let's write the objective function is this green square. This is a minimization problem. We're trying to minimize the cost, the total cost. And the cells are going to be, the variable cells are going to be the ones in yellow. There you go. Now constraints. So the first set of constraints is the number of available units equals the demand. The next set of constraints is regular production less than or equal to 0. The next set of constraint is overtime production less than or equal to 0. The next set of constraints is the maximum number of units in inventory. That means this line less than or equal to 7. The next set of constraints is this number. The sum of the maintenance variables has to be equal to 2. The next constraint is constraint B, this number less than or equal to 1. The next set of constraints is constraint C, this cell less than or equal to 0. Now, those are the constraints of the model. Now we have to specify the nature of the variables. The nature of the variables is going to be specified as another constraint. So let's add another constraint. Regular production, overtime production, inventory, all of these variables are integer. And then maintenance, the last row of the variables is binary, so we select bin like that. And that is the solver. Let's solve this problem and see what the optimal solution is. So we get the optimal solution already. This is the total cost, and this is the production plan. So let's see, maintenance is going to be performed in week 1 and week 5. Production, so of course you cannot produce anything either on week 1 or week 5. So if we have if we had demand for week 5, then we have to store some units in inventory, 7 units in inventory on week 4, and because we are not going to produce anything on week 5, we are going to use those 7 units to cover the production on week 5. So the production is as follows. We are going to produce 7 units on week 2, and we're going to store them. So on week 3, we produce 15 and 6. That's 21 plus the 7 units. Store at the end of last week gives us 28, which is the demand. We're going to cover the demand. So we're not going to have any units at the end of that week of week 3. Week 4, we produce 15 and 2, have nothing on week at the ending of week 3. So 15 and 2 are going to cover the demand, and we're going to store. So 15 and 2 is 17. We're going to use 10 out of those 17 units to cover the demand, and then 7 units to store that are going to be stored for week 5. So in week 5, we're not going to produce because we're going to perform maintenance, but we're going to use these 7 units at the end of last week in order to cover the demand. So there is no production on week 5. On week 6, we're going to produce 15 units, and that's going to be enough to cover the demand. On week 7, we're going to produce 15 units. We're going to use 10 in order to cover the demand, and have 5 units in inventory for next week. So next week, we're going to have 15 units, produce 15 and 3 on overtime, plus the 5 units. That's going to give us 15 and 3 is 18, which are going to be used to cover the demand, and the 5 units are going to be just stored for next week, for week 9. So week 9, we produce 10 and 10, that's 20, but we need 25. We're going to take 20. We're going to take 5 units from last week in order to cover the demand. All the constraints are less than or equal to 0, less than or equal to 0, 7. Constraint B, that means yes, we are performing maintenance on week 1, but not on week 2. And we're not performing maintenance either on week 3 or week 7. It's constraint C. So that is the production problem. That is the production problem solved in Excel, using Excel solver. So I thank you for listening to this video. If there are any questions, comments, or observations, please write them on the comment section. And thank you for your attention.